Hello everyone and welcome back to the IGCSE 0606 Cambridge Additional Mathematics course. In this video we will be covering the 13th chapter, which is vectors in two dimensions. Let's get started. Now this is the actual more complete whiteboard I've made with the notes that you should need. However, I the purpose of this video is to actually explain the concept a bit better, which you can't actually obtain from the notes, but only from watching this video. So I'll actually do the explanation below this, but if you ever want to refer to something, then just use this as a more cheat sheet kind of thing. But if let's get started here. So let me just do a quick introduction. I'm assuming everyone will be familiar with this. This is called a Cartesian plane or the coordinate plane, and you obviously have the x-axis here and the y-axis here. So on this, we are able to represent points like this with some x coordinate and some y coordinate, and we write it as x comma y. And then obviously that is the distance from the origin horizontally, which is x, and then vertically, that will be your y. However, vectors allow us to actually represent this same point with respect to the origin as this straight line here. So obviously we'll have x here and y here. So what we write this as xi, and then this is called an I cap, and that basically symbolizes that you're actually doing vectors here and I is in some other variable, and then yj. So if we were to, let's say, name this point as A, here also this is A, so we would say OA, where O represents the origin. So this arrow shows that we're going from O to A, then that is xi, meaning x in the horizontal direction, or x units in the horizontal direction, and then y units vertically upwards. So obviously if this was negative, then we would have negative y over here, and then that vector would look something like this. Let's say B, so OB will be xy minus yj. Same thing if it was negative x or something like that. But that's the introduction to vectors. So now I'll jump into a bit more complex topic. So let's see. Okay, so vector notation I'll just introduce. So as let's take the above example. Let's take an example here actually. Let's say 5 comma, let's say 1, and then I have this vector here. So let's say call this point A. So we would say OA is equal to, now sometimes this will, in the question paper, the vectors will also be given as a singular letter, but this letter will be in bold, so that represents a vector. So don't write this, but if it's given in the question paper, don't get confused. And then obviously we just learned 5i. Now 1j can just be represented as plus j, because we don't need to actually write the ones, similar to how in algebra we just write x instead of 1x. There's another form. Now this is a column vector, 5 comma 1, and now this is what is used in linear algebra, but that's out of the scope of this syllabus currently. So these four things all represent the same vector. Obviously these two are what we'll actually be using to do the calculations and whatnot that uh, are related to vectors. So that's then okay. And then okay, so we also have position vectors. So what I just discussed are position vectors, and position vectors are basically relative to an origin. um, so like position vectors are relative to a point. So we could also have another vector. Let's say we have some vector A here, and then we have some vector B, let's say in this direction. Okay, then AP will actually be this vector, right? Because with our logic of this, where the arrow represents we're going from O to A, well then AB will actually represent us going from A to B. Now, if we look at that, to go from A to B, we obviously have this direct path. But if we're given OA and OB and we need to find AB, how do we do that? Well, let's see. So we can go from A to B in this direct way. This is one way. Or we can go from A back to O and from O to B. So then this entire direction. So AB, let's say, is A to O and then O to B, right? Now this is AO. How does this relate to OA? Well, that is just negative OA plus OB, as you can see. So because this vector was OA, then its opposite direction will be negative OA. And then obviously if we were to put the positive first so that negative isn't in front, this looks a lot more cleaner. So this is actually a formula where AB is equal to OB minus OA. So if B was replaced by C, it was OC minus OA. And then yeah, basically if you were to replace either of these, then just same thing here that would take place. As you can see here, this is what I just talked about. Now I guess I should also go with okay, okay. So now obviously we have learned vectors, but what about the magnitude of the vector? Like let's say take this vector here, 5i plus j. What is this length of this vector, or what is the length of this line? Well, you can just use the distance formula to find this. So if we represent the sorry, I actually do this. So we represent the length of a vector via the modulus symbol. So the vector is encased inside the modulus symbol like this, and this is just the distance formula. So x squared plus y squared, or x2 minus x1 whole squared, because this is relative to an origin, we just take x1 y1 as 0 0, so that just becomes x squared plus y squared. So 5 square root x squared plus y squared, which is the square root of 26. And then this this can't be simplified further, so we'll just leave it like that. But that is the magnitude of a vector, or the length of this line. So now there's another thing, unit vectors. So what is a unit vector? So I'll type this here, a unit vector. Okay, so unit a unit vector is basically a vector with magnitude 1. Okay, so that's the very simple definition. So if we take the same example here of 5 and then 1, so we have this, and then we obviously know that, let's say this is vector A is obviously square root 26, so its magnitude is obviously not 1. So how do we find a vector with magnitude 1, or how do we represent this as a vector with magnitude 1? Well, you can actually do something that, so the unit vector here represented by, again, the gap will be A divided by modulus A. So we have 5i plus j divided by root 26, so it becomes 5 by root 26 I plus 1 by root 26 j. And then if you actually use your calculator and check this value, it should come out to 1, which it does. So the modulus of this vector, or the unit vector of A, is 1, as we found. That is the definition of a unit vector. Okay, now I'll also teach you some basic vector arithmetic. So if you're given two vectors, x, let's say, actually I'll take in column form. So remember, this is ai plus bj, and then ci plus dj. This can just be represented as a plus c and b plus d. So we actually add the like terms. So ai plus ci gives us a plus c times I, or the whole thing, and then similar. So I can just do plus or minus here. So same thing. Now vectors multiplication is out of our syllabus. So we only have vectors multiplied with scalars, which basically just give us the same thing, and just multiply the each value individually by a scalar value, by the scalar, and you'll get your answer. Now another interesting thing to note here about vectors is, let's say I'm giving this vector 1 comma 1. Okay, now if I multiply it by some scalar value, let's say 3, so that will obviously end up as 3 comma 3. What you'll see is that this vector is actually, it obviously goes through that vector, but essentially if we do vectors if two vectors can be represented as scalar multiples of each other, they are parallel. Okay, and obviously we understand what parallel means. It means they have the same direction. So if they can be represented as scalar multiples of each other in this way, then they'll be parallel. Now we also have an equation of a line. So if we're given some vector, let's say we're given some point here A, and we're told this is another point B, and a line passes through A and B, we have to find the vector direction of this line. So obviously we have the Cartesian equation of the line y is equal to mx plus c that we're familiar with, but we also have a vector equation which is r is equal to a plus lambda b. Now I'll explain to you what this means. So a is just any point that lies on the line, so we can just say r is equal to oa because oa is a point that lies on the line, plus lambda. I'll come to what lambda is in a second. Now b represents the direction of the line. So as we can see, the line is actually going from A to B or B to A. It doesn't really matter. We can just take AB because it's a bit simpler to deal with. We understand the idea of obviously the positive gradient here rather than going backwards. Now lambda can take any value, any number, any real number that is. So let's say if I were to take an example, okay, it'll be much simpler. Let's say 1 comma 2 is our A, and then we have, let's say, 3 comma 5, let's say, is our B. Okay, so if we were to find m, let's just do that first. Y minus 2 over 3 minus 1 is equal to 3 by 2, and obviously so y minus 2 is equal to 3 by 2, x minus 1, so y is equal to 3 by 2 x minus 3 by 2 plus 2, which is positive 1 by 2, right? Minus 1.5, yeah, positive 1 by 2. Now this is the line in our Cartesian equation. What we have here, r is a general point on the line. I forgot to mention that before, but r is a general point on the line. So we've got I plus 2j, which is our OA, plus lambda, and then AB is OB minus OA. So 2I plus 3j. You can actually, if you want, you can write this step out before, because you obviously aren't familiar with vectors as of yet. So I did it directly, but I would recommend obviously writing out the steps. So if we actually look at this, I plus 2j plus, this is the vector equation of the line. So let's say we substitute lambda is equal to 0. So then we'll obviously end up with r is equal to I plus 2j. What point does this represent? Well, it represents the point A. If we were to say lambda is equal to 1, and then this would become 1 plus 2 is 3i, and 2 plus 3 is 5j. What point does this represent? Well, this represents point B. And then same thing, if we were to represent lambda, let's just set lambda as 2. So 2 into 2, 4, 4 plus 1, 5i. 2 into 3, 6, 6 plus 2, 8. So this will be another point on the line. Obviously, we haven't represented that yet, but this will be another point of the line. And then we can obviously, well, these two we know exist, but let's check 5 comma 8 is a point on the line. This should be the same thing. So let's see, what is this? 15 by 2, 16 by 2 is indeed equal to 8, and 8 is equal to 8. So we know both equations, the vector equation and the Cartesian equation, give us a point 5 comma 8 on the line. So that is the vector equation of a line. Now um, there's also vector geometry. So like you'll be given some vector A, another vector, let's say B, and then some third vector, let's say C, this way, right? uh, and then the question will probably be like, oh, A, B, C represent a triangle, and then do something with this triangle, or you'll be given more complex shapes and things like that. So this obviously varies on a case-to-case basis, but essentially you'll have to use one of these techniques to find whatever answer they're expecting of you, given the diagram, or well, given any information that they give. So now let's move to I guess Vector addition, obviously we did this, but this is an algebraic one. Let's look at it a bit more diagrammatically. So if I'm given some vector, let's take a simple vector here, A, and this has only an I component. And if I take a vector B here, this is only a J component. If I were to add them, let's say this is 5 and this is, let's say, 6. Well, what's 5 comma 0 plus 0 comma 6? Well, it's 5 comma 6. What is that vector? That's this vector. So we said this is A plus B, and obviously like that, that's vector addition. There are some more complicated cases, but again, that varies from a question to question basis. Now let's take the same example again. 5, 6. How do we find A minus B? Well, the first thing to do is take the opposite of B, which is negative B. This will be negative 6. And then we just add it together because A minus B is equal to A plus minus B. See, these are the same thing. So if we just take it like this will be our vector 5i minus 6j. So that's vector addition and subtraction diagrammatically. We also have something called as vector resolution. So we just added vectors here, right? What if you were, I don't know, given if you were given the sum vector? Let's say I am given some vector c here, that is the sum of two vectors, and I need to find these two vectors that added to give c, the horizontal and the vertical. Well, you'll need another piece of information, that is the angle theta, either this angle or the angle relative to the y-axis. And what this basically allows us to do is that, so if we can use trigonometry, so what we do is we can form a triangle like this, where this is c, this is theta, so we will label this as a and b, and then if we actually use trigonometry, we can see that sine theta is equal to b by c, so b is equal to c sine theta, and then cosine theta is equal to a by c, so a is equal to c cosine theta. And then using c, or the magnitude of c essentially, you can find the value, and using the value of theta you can find the magnitudes of a and b. Obviously it'll be difficult to find, and then obviously once you found these magnitudes, if we take a to act as only horizontal, we know that is a j component of 0. So whatever that magnitude is, that is the same value of the coefficient of I essentially. And I suppose that's actually it for vectors. I think, yeah, so yep, I think we've covered all of vectors. Thank you for watching.